outside, just don't show it, just don't draw it. That's a simple topic. And last class we discussed about Sutherland, and now we'll see how exactly to clip this kind of a polygon. Well, welcome to my session. So, polygon clipping. Today we'll have two windows. If you have any doubts, you please let me know here. All right. So polygon clipping is a classic clipping of a polygon, which has four processes. One is you can take a polygon like this. Four processes in the sense you should clip the top angle, the bottom one, the right one, and the left one. For example, if this is the polygon and this rectangle or square is your clipping window, and if the black triangle is, if that is your polygon, how exactly you can clip? Follow these four processes, you will end up this. So this is your output, and finally this should be your output. So input is your, output is your. So take the input. First, you need not necessarily have to follow this itself, top, bottom, right, left. You can follow any sequence. All right. So the first step is top clip. So the top portion, you clip it, you will get this output. And the next one is bottom one. So since in the bottom side there is no polygon, so the input remains as output. And for this output, you clip the right portion. So this portion will go off. You will end up with this. And for this guy, you clip the left one. So in the left side of the window, there is no pixel. This is my output. So if you give any input like this, and if you follow top, bottom, right clips, you will end up you will end up the output as something like this. So how do we do this? Well, again, the calculation of intersection point comes to the rescue. If you remember this, we calculated all these intersection points. So here, all these hangama is not there. So simple mathematics, I'll show you now. So take any polygon. This requires a bit of animation. Let me show it full screen. All right. If you have any polygon like this, and the blue window is your clipping window, and if this is your polygon, follow four steps. Take the let's say right one, so clip off. Next, take the bottom one. If you apply the Sutherland Hodgeman clipping, which we shall discuss in 2 minutes, you clip it off, you will get this. And the left one, this is the output, and the right, the top one, this is the output. So the case studies can be something like this. Will this work for a non-rectangular clip regions? Means to say my clipping window is rectangle in all my cases, and if I say any non-rectangular clip regions, let's say you take a circle, you take any other polygon, will that work? The answer is no. Would that involve any 3D clipping? Something to be pondered upon. All right. So we shall see this. In this case, if you can consider this as if I write the word called inside, that means the polygon is inside the rectangle, inside the clipping rectangle. So no need to clip. So for example, if you take this line SP, which is already inside the clipping rectangle, so the output is also same. The second case, SP line, S2, you can consider the intersection point as P dash. The line is SP, the S2, the intersection point is inside my clipping rectangle. The intersection point to the final point called P, this region is outside my rectangle. So in that case, you should consider the intersection edge. something like P dash. The output is P dash. What do you mean by input? What do you mean by output? Which we will see in a couple of minutes. The third case is, let us say you understand that these three lines are inside the clipping rectangle, and if my line that needs to be clipped is SP, which is totally outside the clipping rectangle. In that case, if you apply the Sutherland Hodgeman clipping algorithm, the output is no output. I can say nil. I'll repeat. There are two cases. One is inside the rectangle, one is outside the rectangle. If you take SP, if the line that needs to be taken care is SP, and you can see SP, both S and P points are lying inside the rectangle, the output is the second point called P. Now the second case, if your line that needs to be taken care of, or if your line that needs to be clipped is SP, and you can see some portion is inside, some portion is outside, the output of this algorithm is the intersection point. Third case, if the line is SP and both the points S and P are outside, the output is nil. Means your input is something like this, the output is nil, because this is already anyway clipped outside the rectangle, so no need to apply this algorithm itself. Even if you apply, don't consider this. That's the theory behind this. All right. The fourth case, it is coming from outside to inside. What is the story here? It is inside, the arrow mark, inside to outside. The output is the intersection point. If the line is coming from outside the clipping rectangle to inside the clipping rectangle, the output is this, again, the intersection point. So you should, of course, there are 2 points here. One is intersection point and till the point that is inside the rectangle. So in this case, both the inside point and the intersection point are your outputs. So don't worry, we will clarify this in a bit. Let us take your textbook. This is page number, I guess, 329. If you open the book or prescribed book 329, the polygon fill area clipping comes. I have extracted 7 pages for today's class. Now, before clipping, after clipping. So whichever pixels comes inside the rectangle. So before clipping and after clipping. And yeah, this is also we taught original shape. If you apply left clipping, so this area will go out. Clip right, this area. Clip bottom, all these pixels will go out, and clip top, you will end up with this output. This is what we have seen. And now, yeah, one more example in your textbook, clipping rectangle, polygon. This is the output. Now what I want now is, yeah, this one. All right. So first case, you are going from, so understand this, the dotted rectangle is your clipping rectangle. This light blue color shape is your polygon. Now what points are inside? These points are inside, and these points are outside. For example, V1 is outside, V2 is inside. You can see this arrow mark here. It is going from output, that is the outside the window, to inside the window. That is what is this, out to in. So in out to in case, the output is the intersection point to the final point. That is what we saw here. Yeah, out to in, the output is the intersection point to the inside point. So that is what we saw here. Out to in means outside, V1 is outside, to V2 inside. The output is the intersection point to final point. Next case, in to in. So the PPT says inside, inside. is that? Okay, here we don't have anything. The fifth case can be inside inside. We have seen inside outside. Okay, yeah, this case. So both the points are inside. The output is the second point. So you can see V1 to V2, both the points inside to inside. The output is the second point, that is V2. That is what the PPT says. So S and P, both the guys are inside. The output is P, second point. So V1 to V2, first point, second point, in to in, inside to inside, the output is the second point, V2. Don't worry, we will understand this more clearly in this problem. All right. Third one. Next case is inside to outside. So inside, yeah, this one, S2P, inside to outside, the output is the intersection point. So V1 to V2, inside to V2, inside to outside, output is the intersection point called V1 dash. So this is V1, this is V2, intersection point happens to be V1 dash. So inside to outside means the intersection point is V1 dash. Fourth guy is everything is outside. So S and P both are outside. Output is nil. So output to output, that is the outside to outside, output is none. We will apply all these understandings in this simple problem. That will end our discussion. All right. So take this dotted rectangle, consider this dotted rectangle as clipping rectangle. These are this is my polygon. Initially, polygon has only 3 points, 3 vertex, 1, 2, 3, and these 2 dash, 2 double dash, 3 dash, and 1 dash, which we will calculate now. These are intersection points. All right. Now what we will do is take this rectangle, take this polygon. First, you can follow any sequence. We will follow this LRBT concept. All right. So first one is you can now understand which portions are inside and which portions are outside. For example, 2 to 3 means there is inside to outside, and the intersection point is 2 dash. So 2 dash to 3, you should not at all consider any doubts. No doubts. All right. All right. You can see here any doubts, or if you are not able to hear me, please give me a chat here, so that that is the reason I am keeping 2 windows open. Now if you look at here, take this polygon input, apply left clipping. Now there are 2 sections here. One is the edge window, next is the operation window. In the edge window, you should write the edges. In the operations window, you should write these operations. All right. Now, first edge window, we will take it as 1, 2. Now understand, if I write 1, 2, I am actually going from 1 to 2. So the arrow mark something like this. So 1 to 2. That is, you are starting from 1. Oh, yeah, very simple algorithm. You can see here. 1 to 2, this was what I was discussing. So you are going from 1 to 2. And 1, 2 is, I understand 1, 2 is here, but you are applying what clipping? You are applying left clipping. That means clipping window is here. That means you are applying the left clipping. So for this case, 1, 2 lies inside to inside. Don't consider 1 and 2 here, even though it is here. But where am I? I am in this left clipping. So for me, if I am here, both the guys 1 and 2, since 1 and 2 is not appearing here, for me 1 and 2 looks that, because it is not visible here, I understand that 1 and 2 both the guys are inside to inside. So if it is inside to inside, V1 to V2, the output is second point. So inside, 1, 2, 1, 1, 2, the output is the second point called 2. Second one, I'll go from 2 to 3. So 2 to 3, yeah, since I am here in my left portion, 2 to 3 means it is in to out. So if it is in to out, the output is the intersection point. So if it is 2 to 3 in to out, the output is intersection point. So that is 2 dash. All right. Next one is 3 to 1. So 1 to 2 is over, 2 to 3 is over. Next is 3 to 1. So I'll earmark. I am here left side 3 to 1. So this is the clipping rectangle. 3 is outside. 1 is not visible. So I will understand that 1 is somewhere inside. So that is the reason it is outside to inside. So 3 is outside, 1 is inside. So if it is outside to inside, this case, outside to inside, the output is the intersection point, second point. So intersection point to second point. So 3, 1, intersection point is 3 dash, second point is 1. So the output is 3 dash 1. You understood? All right. So left portion is over. Next we shall go to right portion, that is right clipping. I'll repeat again. Take this polygon. First is apply left clipping. So left clipping start from 1 to 2. 1 to 2, 1 and 2 are not seen in the left side. I will imagine that 1 and 2 are inside. So inside, the output is the second point called 2. Next is 2, 3. It is inside to outside. The output is the intersection point called 2 dash. 3, 1, that is outside to inside. The output is intersection point, second point, that is 3 dash and 1. All right. Next one is we will consider right clipping. In the right clipping, you can see 1, 2, 3, 2 dash. These guys are not at all visible yet. So for me, everything is inside. That is the reason I'm saying inside, all this. But it is our duty to traverse all the edges. Now, what you should consider as input now. Now, the input is after once you're done with the previous operation, that is the left operation, whatever is the output, you need to consider these along with any other pre-processed edge. All right. So now we have 2, 2 dash, 3 dash, 1. So you should have these combinations itself. All right. Now you are in the right hand side, that is the right clipping. So 2, 2 dash, 3 dash, 1 is what is your output. So you should play with these 4 vertices. You can see here 2, 2 dash, 2 dash, 3 dash, 3 dash, 1, 1, 2. So you should play with only these. All right. Now, so let us consider first 2 now, 2 to 2 dash. So 2 to 2 dash, I am here in the right side. So since no pixels are available here, I'll consider everything to be inside. So 2, 2 dash, inside. Inside means output is the second point. So output is 2 dash, second point. All right. Next one in this combination, 2 dash, 3 dash, and 3 dash to 1 and 1 to 2. All right. So 2 dash to, why can you tell me why am I not going? See, first step is I went to 2 to 2 dash. Second step, if you should have got this doubt, why am I not going from 2 dash to 3? Why 3 I am not considering? Why 3 not considering is in this left hand output, left clipping output, there is no 3. That is the reason I am writing 2 dash, 3 dash, 2 dash to 3 dash, not 2 dash to 3. So I am here now. So 2 dash to 3 dash. So since I am here, I'll consider everything to be inside. So in the output is the second point called 3 dash. All right. Next one, 3 dash to 1, 3 dash to 1. Again, inside, the output is the destination. The second point called 1. Next is 1 to 2. I am here, so no pixels are found here. I consider that everything is somewhere inside. So 1 to 2 again in the output is second point called 2. So the outputs are now 2 dash, 3 dash, and 1 and 2. So you should play with these now. So where are you now? You are in the bottom. That means you are here. The bottom. You are here now. Now consider this 2 dash. This is 2 dash 3 dash. So take this edge 2 dash to 3 dash. Now you are here. You are here now. Please use only your official email IDs. So you are here now. So this is outside, this is inside. 2 dash to 3 dash means inside to outside. So inside to outside means the output is intersection point. So 2 dash to 3 dash, the output is the intersection point. Let me write it as 2 double dash. So inside to outside, 2 double dash. Next, 3 dash to 1. Since you are here, 3 dash to 1, both the guys are outside to outside. That is outside to outside. So 3 dash 1, outside, outside. So in this outside, outside case, the output is none. That means don't consider at all. So output is empty bracket, null. Next, 1 to 2. So you are here now. 1 to 2 means outside to inside. Can you tell me? Outside to inside, the intersection point is, the output is intersection point, comma, second point. So outside to inside, the output is intersection 1 to 2. Outside to inside, the output is intersection point to second point. That is 1 dash to 2. That is what you have got here. Next, you are remaining with other edge 2 to 2 dash. So 2 to 2 dash, 2 to 2 dash here. And since you are at the bottom clip, 2 to 2 dash are not visible here. So I will consider both the guys are inside. So inside means the output is the second point called 2 dash. So I will write 2 dash here. Now left, right, bottom is over. Next we shall apply top. It is fairly easy now. In the top means no pixels are available here. For me, everything looks inside. So you can see everything is inside. So what pixels you need to take here? It is 2 dash, 1 dash, 2, 2 dash here. I think this is 2 double dash, 2 dash, 2 dash. Yeah, this is 2 double dash. This is 2 double dash, 1 dash, 2 dash. So these are my input edges. So for the top clipper, okay, since no pixels are here, I will consider everything as input. So 2 double dash, 1 dash, 2 double dash, 1 dash. So since 2 double dash 1 dash is not found here, I'll consider everything as inside. The output is the second point called 1 dash. Sorry for this textbook export. That is the soft copy is this itself. If you can purchase this book, it's wonderful. It's in the library as well. So 1 dash 2, 1 dash 2, both are anyway inside. Take output as 2. 2 to 2 dash. Output is 2 dash, 2 dash to 2 double dash, output is 2 double dash. Now what are we doing? Consider this last output. This is 1 dash 2, 2 dash, 2 double dash. So 1 dash 2, 2 dash, 2 double dash. Apparently what is this? 1 dash 2, 2 dash, 2 double dash. These are my output. Means if this is the input, output is 1 dash 2, 2 dash, 2 dash. So these pixels I need to highlight. 1 dash to 1, 1 to 3, 3 to 2 dash. These pixels are not coming here, so they are left out. So clipping window is this. input is this polygon, output is 1 dash 2, 2 dash 2 dash. So I hope you have understood Sutherland, Hodgeman, and Polygon. Now, once you know this mathematics, in the textbook he has given the meaning of these mathematics. So just go through. So there are 4 cases, means there are 4 cases here. So he has explained, for example, if the first input vertex is outside, that is V1. This clipping outside this clipping window border, and the second one happens to be inside. Both the intersection point of the polygon edge with the window border, and the second vertex are sent to the next clip, that is V1 dash to V2. So whatever we discuss mathematics, nicely being framed into English. So please concentrate. So this finishes off Sutherland Hodgeman. The same thing, whatever we discussed for Cohen Sutherland, Sutherland Hodgeman also has the program, the whatever we have discussed here. It is being neatly jotted down in terms of the program. So this finishes off Sutherland Hodgeman. Wheeler-Atherton polygon clipping is not there in your syllabus.